For more than 2 decades, Palram has helped architects meet new design challenges with its innovative line of polycarbonate glazing and roofing materials. This versatile building material allows architects and designers to create structures that are original, practical, and sustainable. Today, Palram's polycarbonate panel innovations are widely specified in thousands of notable projects worldwide. The broad use of polycarbonate in world-class sporting venues, airports, and other large-scale commercial buildings underscore its reputation as a safe, predictable, high-performing building material. Innovative polycarbonate products combined with industry expert assistance. That's freedom in design. That's Palram.
So hello everyone. Thank you for being with us. My name is Furman. I'm Palram Chief Engineer. Today with me is also Mr. Greg O'Driscoll. He is Palram Project Sales Manager in the United States. And today we're going to have a webinar about innovations in commercial building design with polycarbonate. So the webinar agenda, first we have a general introduction in order for you to better understand who is Palram and what are the benefits when you're partnering with a manufacturer who has a wide range of polycarbonate solutions. We talk about 2 case studies locally in the States, the Riverview condos in Florida and the Aurora Clock Tower, to better understand the working process when we are involving in it. Then we talk about the benefits of daylight, why do we need it, and what the benefit it gives us in commercial buildings. Then we'll have a short review about polycarbonate as a building material. We will see the different polycarbonate types, the comparison between polycarbonate and other building materials. Then we'll see some consideration we need to take when we're specifying polycarbonate, especially when it's relevant for roofing and facades. And then in the end, we'll have questions and answers. So if you have questions, just bring it up in the end of the webinar. Okay, so today in the webinar, if I would like you to take one memory from this webinar, this would be it. I would like you to remember that we can offer you the architectural products, we can offer you the project services, we can offer you the ongoing support, everything in order to have a complete and a successful project. When I talk about architectural products, you will see later on in the webinar what kind of products we can offer you. When we talk about project services and ongoing supports, I'm talking about shop drawings, design meetings, sometimes even site visits. And we are doing that in order that you and us both will have a complete and successful project in the end. So the next slides, we're going to talk about the 2 case studies. So it will be presented by Mr. Greg O'Driscoll. So go ahead, Greg.
Thanks, Tal. As you said, we have 2 unique cases to present here, case studies. The first is a remodel retrofit at a Florida condo association. In Florida, the condo association had glass canopies over 2nd-story walkways to protect the residents going to and from their condos. You can go to the next slide, Tal. The strong Florida sun had continuously broken down the seals between the panels, allowing water to penetrate to the wood structure. This allowed algae to form along with condensation as seen in these pictures. With a weakened support structure and the constant threat of potential hurricanes, it was only a matter of time that these panels would become a property liability. So the owners considered one option, which was to replace the glass and structures as they failed. Unfortunately, this option was not cost effective and did not reduce the liability for the homeowners association. The second was to remove it altogether. The homeowners voted this down as they were used to being protected from the sun and the weather walking to and from their condos on these exposed walkways. Palram's proposal, and you can go to the next one, Tal, was to supply a material called Sunglaze 4600. And this was accepted for a variety of reasons. First, it's lighter than glass, so the support structure could be replaced with a new lighter method using aluminum instead of pressure-treated lumber. Second, it is guaranteed to be watertight. The option provides protection for years to come, and with Miami-Dade certification, the solution supports the environmental demands and constant hurricane threats on Florida's East Coast. Last but not least, it's a cost-effective solution to purchase, install, and maintain. This was important to the condo association and its board of directors because they have at least 5 more buildings with the same aging condition. We'll go to the next one, Tal. The second case study is a landmark for a new multifamily development in Colorado. And here a developer and architect had a design that called for a landmark tower to mark the entrance of a new 4,000-acre residential development. This tower was proposed to be at 110 feet in the air, and it would serve as the beacon and entrance of this new development. The architect's design was to build a clock tower that could be seen from many miles in any direction. First proposed using a glass face, the structure to support the clock was large and expensive due to the weight of the glass. Backlighting a multi-wall solution was discussed and approved by the client and the architect. But standard multi-wall needed to be supported on all 4 sides to meet the high wind load demands and could not be a recommended option. Mock-ups were supplied of Palram's SunPal 18, as you see here in these pictures, connected using a hidden seam or reverse fixing method to handle the high winds seen in these details, provided by Palram in a set of shop drawings. The next slide, Tal. Next was the color of the panels. Since multi-wall comes in a variety of colors, the client had options. After a couple of mock-ups, white ice was selected for maximum light diffusion and transmission. By using a multi-wall system versus glass, the client built a support structure much more cost-effectively as the weight of the SunPal is less than 3/4 pounds per square foot. Palram then provided panels cut to size. This proved labor-saving, and the installer had little trouble converting a radical design to a finished landmark. Go next slide, Tal.
Okay, thank you, Greg, for presenting these 2 case studies. Now we move on with the presentation, with the webinar, and we talk about the benefits of daylighting. So research shows that when you have a natural daylight in your office building, the workers perform 25% better than artificial light office spaces. Also, when you have it in your classroom, students' learning rates improve by 21%. When you go to hospital, so patients in hospital recover faster when they have natural daylight. And in commercial buildings, it shows that sales increased by 40% when you have a store with natural daylight inside. Now, I want to show you a quick a small case study about natural daylighting, and this is in a warehouse in Mexico. So you can see here the before picture. What you see here is a warehouse in Mexico, as I said. The area is about a little bit more than 59,000 square feet, and the current light. The current light source is artificial lighting, and they have about 550 lux. They decided to to add some natural daylight into the building. So every 8th panel they took off and they put a polycarbonate panel instead. And this is the result. Okay, so you get a natural daylight. So basically they put 12% of the total roof area as a polycarbonate skylight. It cost about $23,650. They got 1,100 looks inside now, almost double. And the annual cost saving is about $10,500 US. So the return of investment is about in 27 months. And this is when they just decided to take every 8th panel out and put a skylight inside. So you can see the difference and understand the benefits. Okay, so typical variation of polycarbonate sheeting. So what you see here are the most common types of polycarbonate sheeting. You have the flat solid sheets, what we call the glass-alike. You have the profiled, or sometimes we call it corrugated. We have the multi-wall, and we have the panel systems. So let's talk first about the multi-wall in a very high level. So the common thicknesses are 4 to 40 millimeters. Light transmission is up to 80%. The R value, it can go up to 4.2. And the installation method is usually with polycarbonate or aluminum profiles. When we talk about commercial buildings, usually it will be with aluminum profiles. With polycarbonate profiles, it will be more industrial or domestic or greenhouse oriented. The main benefits of the multi-wall, of course, it's very lightweighted. It has excellent thermal insulation. It has the ability to diffuse the light. We'll talk about this later on the webinar. And it's very easy to curve. So if you have a curved roof, it's very easy to cold bend it during the installation itself. No need for heat treatments and other stuff. The flat solid polycarbonate at a glance. So the common thicknesses are 3 to 15 millimeters. In architectural projects, we will rather be above 6 millimeter as a thumb rule, but we can also get it in less than 6 millimeters. The light transmission is up to 90%. So if you take it in clear without any color, it's as clear as glass. The R value, of course, is much lower. It's depending on the thickness, and the maximum you can get is 1.3, more or less. And the installation method is with aluminum profiles. So basically, it's being glazed. The main benefits of flat solid polycarbonate are, of course, the lightweight. It's less than half the weight of the glass. So this has a very big impact on the supportive structure. It's transparent as glass. It has an excellent impact strength, 200 times better than glass. So it is almost unbreakable. You can say it's unbreakable. It has acoustic insulation ability, and it can be curved easily. As we talked before, you will see some pictures in the next slides showing you a very nice cold bending installations of polycarbonate. The profiled polycarbonate, or what we sometimes call corrugated polycarbonate, the thickness is from 0.8 to 3 millimeters. Light transmission is up to 90%. It's very clear, but not clear as glass because of the corrugation itself. It's a little bit makes some distortions, but it's providing you up to 90% light transmission. The R value, as I told you before, it's depending on the thickness, so you can get up to approximately 1. And the installation method is screws. Basically, you are screw fixing the material to the supportive structure, and it's being watertight by rubber gaskets. So the benefits, of course, it's lightweight. It's transparent, it has excellent impact strength like any other polycarbonate, and it's very easy to install. Polycarbonate panel systems. So the difference, for example, between the panel systems and the standard polycarbonate multi-wall or profiled or flat solid is that it all comes together as we can say as a kit from the manufacturer. So basically you get all the accessories, all the finish accessories. If you need aluminum profiles, everything comes as a single source from the manufacturer. So basically you get the sheets and the accessories. The R value, if you're using a single layer, can be up to 3.8. If you're doing a double layer, it can be almost 7.6. And the installation method will be either polycarbonate or aluminum profiles. As it's written here, it's included in the system. So based on the project, you will get the needed accessories for the installation. Now, the main benefit when you use a system is of course, you have a full system kit. So you get everything from a single source. You don't need to source anything by yourself. It's completely leak-proof, and if it's installed according to our instructions, we can also issue a leak-proof warranty. The design incorporates free expansion and contraction because of temperature difference, and it's very, very easy to install. So you save a lot of money on labor cost because you can install much more square feet per day. Okay, the importance of thermal insulation. So if thermal insulation is high priority, then multi-wall polycarbonate may be the best solution as it delivers the highest thermal insulation levels of the polycarbonate sheets, not to mention other glazing materials. With solid polycarbonate, whether profiled or flat, the thickness of the material determines the insulation values. With multi-wall, for example, both the material thickness and the inner structure impact the thermal insulation. Of course, as we spoken before, it's possible to achieve higher level of insulation by creating special glazing systems that include several layers of panel and air gaps between. So basically what you see here on this slide, if you look on the right side of the slide, you can see a table showing you the R value of typical thicknesses in solid polycarbonate sheets and the R value on typical thicknesses of multi-wall sheets. So you can see that if you take 12 millimeter solid polycarbonate sheet, it has, let's say it other way, if you take 6 millimeter multi-wall polycarbonate sheet, it has a better R value property than 12 millimeter solid. So if the most important property of your design is thermal insulation, you should go for multi-wall design. If your importance is more to have the clarity, so the transparency, then you need to go with the solid design. Let's talk a little bit about, so we talk about the thermal insulation. Now we'll talk about the importance of the solar spectrum. This is basically the radiation coming from the sun and trying to penetrate into our building. So basically, the solar spectrum is divided into three main groups. We have the UV part, we have the visible part, and we have the infrared part. The UV part is what causes us the, basically it hurts our skin. We get the sunburn from it. So basically we would like to eliminate it completely. The visible light, this is the part that we want to go into the building because it helps us, as you see, as we showed you before, it improves our lives. And the infrared radiation, this part is causing what we call the greenhouse effect. So basically, it's causing a heat buildup inside the building. So in an ideal world, we would like to eliminate this one, to have here as much as possible, and to completely eliminate this part of the solar spectrum. So let's go a little bit deeper into the solar spectrum. So we are now looking on the polycarbonate polycarbonate solar performance in terms of UV blockage. So what you see here on the red part, this is the UV radiation part coming from the sun. Okay, this is the wavelength of the UV part. So you see this is coming from the sun. When we are talking about a standard glass window, so you see it blocks a little bit here, but since this point, it basically transmits all the UV radiation. When we go to a sunscreen with a solar factor of 15, the one that we put when you go to the beach, so you see it blocks better than the glass window, but not as good as polycarbonate, which eliminates everything, almost everything, 99%. Of both UVA and UVB. So next time, if you go to a vacation to an hotel and the swimming pool is covered with polycarbonate panels, you don't need to put any sun lotion because you will not get sunburns. Okay, so we talked about the UV. Now let's talk about the infrared part of the solar spectrum. So basically, we have the standard polycarbonate technology that has a very simple formula. If we are allowing high percentage of natural light into the building, we're also allowing high percent of infrared radiation to go into the building. In the recent years, we have developed what we call solar smart technologies that allows the natural daylight to go into the building through the material, but prevent the infrared radiation to penetrate. So basically, it's reflecting the infrared radiation out, not everything, not all the infrared radiation, but a big portion of it. And by that, basically, we are preventing what we talk about the greenhouse effect inside or underneath the polycarbonate material. So this new technology of infrared blockage, it's called Solar Smart. And we have three types of Solar Smart products. We have the Solar Metallic, which is the first generation. We have the Smart Green, and we have the Bluish Breeze. Let's talk about the difference between them. But first, as you remember, this is the solar spectrum, and we would like to eliminate this part because we don't want the heat buildup into the building. So here on the left side of the slide now, you have a comparison between three types of polycarbonate. We have the clear, which is the standard, what we call glass-alike. We have the Palram Breeze in blue, and we have the Palram Smart Green in the green line. So as you can see, regardless the color, the UV is completely blocked. Okay, this is a graph transmittance comparing to wavelength. So basically, no transmittance in the UV part, regardless the color. When we go to the visible light, so we have 90% for the clear sheet, we have 70% for the breeze, and we have 60% for the smart green. Okay, this is quite high percentage of natural daylight into the building. And when we go to the infrared radiation part, so you see the clear transmit almost all the infrared radiation coming from the sun. So it means that the temperature, when you build a building only using clear material, it will be very hot to sit underneath. It will be like greenhouse. Okay, in greenhouses, when we want to absorb the heat into the greenhouse, we do it from clear sheets because we want the greenhouse effect. But when we do a shopping mall or when we do an apartment building, we don't want this effect. So when you go to the smart green, you see the green line. So here it transmits approximately 10 to 20%, but from this point, it behaves the same as the clear sheet. And when I go to the breeze, which is the latest generation, you see from this part when the infrared radiation starts, it transmits, let's say, approximately 10% in average. And when I'm trying to convert this 10% to degrees Fahrenheit, so if I'm taking a standard multi-wall with the standard color and the same multi-wall with the breeze color, I can have 34 degrees Fahrenheit difference over 500 minutes. So it means after, let's say, more or less 6 hours or 5 hours, you can get 34 degrees Fahrenheit difference only by specifying the Solar Smart family product instead of the standard product. This is a huge impact on air conditioning during summertime, and of course the feeling of people sitting under this material. Another thing that most people always confused about is the solar heat gain coefficient and the R value. A lot of people think they are the same, so they are not. The U value or R value, depending on the country you're from, it's measured the thermal transmittance through a given material, regardless its color and LT. So, for example, if this is a polycarbonate window, and it can be a clear polycarbonate window, or it can be an opaque polycarbonate window, it has this, assuming it's the same thickness and the same material, it will have the same U or R value when I try to calculate how much heat or cool I will lose through the window when I'm turning on the air conditioning or the heater during winter time. The solar heat gain coefficient, it represents the fraction of the solar radiation that enters the building through a transparent or translucent opening in the roof or the wall. Okay, so here the color does matter. Okay, so basically an opaque material will not have any solar heat gain coefficient value. So the solar heat gain coefficient value, basically what we talked before, is trying to prevent the greenhouse effect from the solar radiation. Usually in architectural projects, we would like to be between, when we talk about solar heat gain coefficient, we would like to be between 0.3 to 0.5. This is the, let's say the convenient zone for a human being to feel comfortable with the solar radiation. Now, both of these parameters together play an important role when we consider the energy efficiency of the building. So when you have the, let's say a shopping mall, and you have an air conditioning consultant, so he needs to take all these parameters in consideration when he is specifying the right air conditioning system or the heating system, etc. Okay, another properties of polycarbonate is, of course, the durability of the polycarbonate. Actually, polycarbonate was one of the first materials to be one of the first window glazing materials to be certified by Florida's Miami-Dade County. It has exceptional strength. Okay, you cannot break it. You can take a hammer. You know, when you see in the TV, all the policemen, when they have the transparent shields and helmets, all made of polycarbonate. It has also outstanding resistance to even a distributed load, which make it a very good roofing material or facade material. We have the acoustic performance. Polycarbonate products basically has a very good sound absorption, not absorption, sound reduction property. It works by reflecting. So you cannot put polycarbonate, let's say, in a concert hall, but you can put it next to a highway. So probably most of the transparent acoustic wall you see when you drive a highway are polycarbonate. Another important property is the surface finish. We can provide you two types of surface finish. We can have the matte finish if you want to prevent the glare effect to protect the surrounding from the glare. Or if you want the glare, we can provide it with gloss finish, and then you can see the reflections of the surrounding on the polycarbonate. Another important property of the polycarbonate is, of course, the aesthetics. You can mix colors. You can make different finish surfaces. You can have matte finish. You can have gloss finish. You can put different types of LED lights behind, so you can get a nice night effect. You can digitally print on polycarbonate if you need a certain pattern. We did it before in projects. You can cold bend the panels. It means you don't need to pay extra cost for heat bending. And of course, you have the nighttime effect when you put some LED lights behind. Some typical applications you can see using polycarbonate. You can see, for example, we talked about the cold bending here on the top left corner. The panels here, what you see was sent flat to the construction site, and they were bent during the installation. Imagine you'd have to do that with glass. It would cost a fortune because you need to make every glass a heat treatment to make the curve, and you pay a lot of money just for achieving this. So when you use polycarbonate, it's completely free. You can see here another use of the property of the polycarbonate as a safety glazing. This is a prison. They wanted a high impact resistant material, so if there are some riots or stuff like that, so it won't break. So they glazed all the windows with polycarbonate. You can see here some nice design of acoustic barriers. So it doesn't necessarily need to be only clear, it can be with colors, etc., etc. You can see some sports stadiums, greenhouse, walkways. Okay, let's talk a little bit polycarbonate compared to glass. So what you see here in the picture is actually a project we had in Europe. This is the central bank in Cyprus, and they were looking to replace the old skylights, the old glass skylights. But they were looking for this kind of design, for the arch, for the barrel vault design. So they choose the polycarbonate just because the cold bending effect, the cold bending ability that we previously talked, because it saved them a lot of money. Now, additionally, they specified here a double glazing system. It means they have a very good R value, which means thermal insulation. And because this skylight is above the entire bank, they also consider the solar radiation. So the external layer, what you see here, the external layer of the barrel vault skylight is with the breeze additive. So basically, it transmits a very high percentage of the visible light. This is the part that we want into the building, and it reflects almost 90% of the infrared radiation. So it doesn't create the greenhouse effect inside the bank. Okay, a little bit about polycarbonate as a sustainable material. So the polycarbonate is 100% recyclable material. It requires less energy to manufacture when you compare it to glass or other roofing materials. It's made from raw materials naturally occurring in the environment and minimized waste during production. It means that if something goes wrong in production, and if we have some waste during the production, we just regrind it, put it back in the production line, and we don't have any waste during production. Now, when you consider these 4 factors and you design your building according to the LEED certificates, you can gain some credit points about that as well. Okay, the next slides, you will see some features of the polycarbonate which can get credit points for certification of green construction. such as LEED or the BREEAM building codes. So we talk about the natural light. You can see here, we showed you before the before and after of the Mexico warehouse. So basically it's lower CO2 emissions related to artificial lighting. The daylight connects building occupants with the outdoors, and the quality views give building occupants a connection to the natural outdoor environment. Another quality of the polycarbonate is the light diffusion. You can see here the same picture using here standard polycarbonate material and using here polycarbonate with diffuser additive. So you can see we can get here nice fluorescentic diffusion of the light. So basically we don't have dark spots inside the building. We talked about the heat blocking. By the way, this is the view from underneath of what you showed before, the skylight in the Cyprus Bank. So you can see it's clear as glass. You can perfectly see the clouds, and it's completely blocked, not completely, 90% blockage of the infrared radiation. So we don't let the heat go inside. We have the UV blocking of the polycarbonate. This is an example. This one is a hotel. They covered the children playground with polycarbonate in order to protect them from the harmful UV radiation. About the glare reduction, some people refer to the glare as light pollution. So if you choose the surface finish to be matte, we completely eliminate this. Talk about the thermal insulation. So based on the material or based on the project, we can specify the right solution to have a superior thermal insulation. We talk about acoustic insulation. This, what you see here on the picture, it's an acoustic tunnel. This is in China. This is a highway crossing inside the Beijing Zoo. And this is completely blocking the noise. So when you walk inside the zoo, you don't realize and you don't hear anything, but there is a very crowded highway going through the middle of the zoo. Of course, it's weather resistance. It provides external protection from the elements such rain, snow, hail, and wind. Another very important property of the polycarbonate is the lightweight. So basically, you are saving money on the structural supports because you can use less structural support when you use lighter material. And it reduces the needs for labor during the installation. Mobility. The normal life of polycarbonate is about 40 years. So when you design with polycarbonate, you can design it for 30, 40 years without any fear of replacement. We have the flexibility, the cold bending. So when you do a cold bending with polycarbonate, you negate the need to make some heat treatments to glass or other materials in order to suit the radius. And of course, the impact resistance. Imagine you will have all the storefronts made of polycarbonate. So basically, it's vandalism proof. So you build it once and it's basically unbreakable. Okay, in the next slides, we're going to see some nice projects worldwide. And we see the benefits of polycarbonate in these projects. So this is the Pretoria University in South Africa. And you can see here basically two types of polycarbonate. You can see here, this is the multi-wall system. So this is installed basically about 3 stories high in the air. And they have also standard multi-wall glazed with curtain wall profiles above and under the glass windows. Another project, actually this is quite a milestone project. This is the Aviva Stadium in Dublin. What you can see here, this is how the stadium looks from outside. This is how it looks from the inside. So you can see that the architect, he specified clear material in the front of the roof in order to have the natural daylight to the grass, and he used a diffuser material at the back part of the roof in order the people to sit in the shade. Now I'm going to tell you that these transparent sheets and these translucent sheets, they have the same light transmission. Only this one we produced with the diffuser additive and this one without. So basically you can see the effect it creates. It gets the natural daylight to the grass, to the pitch, and the people sits in the shade. Now, originally in this stadium, the architect design was for 8mm solid polycarbonate sheet. But once we showed him that we can offer him a better solution in terms of drainage, in terms of installation, in terms of ease of installation. So basically we offered him a tailor-made 3mm corrugated solution. And he liked it very much, so he changed his design. And only by changing from solid polycarbonate from solid 8mm polycarbonate to 3mm corrugated polycarbonate, we did a rough calculation, and it saved the project about $3.5 million on material and labor cost. So just by doing that, they saved a lot of money. Another project is this one is in China, the Hangzhou Airport. Here they also used the solid polycarbonate system. And you can see the wavy design here. The original design was for glass, but because of the curve, the cost was very high. So the architect decided he wants to go with polycarbonate. So the polycarbonate was easily cold bended into these values. And what's important in this project is Hangzhou is sitting in the Hangzhou Bay, and once in a while they have typhoon storms, and they can go up to 12 in Beaufort scale. 12 is the maximum, the highest level for typhoons. So the system can withstand these kind of typhoons as well. Another project, this one is from Colombia. What you see here again is the solid system, standing seam system. This is just above the food court part of the shopping mall, where they wanted people to enjoy the natural light, to see the sky, and not to suffer from the heat buildup. So basically, they took it in the breeze color. What you see here is basically this was installed in cold bedding during the installation. What you see here is a step solution that we designed for them in order to have the right waterproofness, because from here to here it was more than the container size, so we had to make a step detail. But as you can see from the design, you cannot see it from underneath. So people sitting inside the shopping mall, when they look up, they don't even see it. They don't know that this is not made out of a single length sheet length. Another nice story is the Essen soccer stadium in Germany. They've built the entire roofing of the stands from perforated metal, and then they realized that water will go inside through the perforation. So they came to Palram and asked if we can help them find a solution. So we designed a special corrugated sheet, you see here on the right top corner, that will sit inside. It has the same shape of the metal standing seam profile, only without the actual seam. so it sits between the seam. It's perfectly matched. And then we also designed a special aluminum clip that once you put the corrugated polycarbonate in place, you just snap it into place and it holds everything together. So basically, we created a multi-layered roofing solution and completely watertight solution. Now, this kind of fixing, it's also expansion-free fixing. So because there are no screws going through the material into the structure. So this allows us to install here up to almost 70 feet long sheets without any longitudinal overlaps. Another nice project, this one also in China, the Hangzhou Stadium. The polycarbonate, the design of this stadium is to mimic the Huangguo Chu, I hope I said it right, waterfall, which are the most tallest waterfalls in China, which are very close to the stadium. So to meet the architect design, we had to polycarbonate sheets were specified in multiple lengths to match the roof oval shape. So basically, if you look here on the picture, you can see the polycarbonate going here all the way to the end to provide the natural daylight to the pitch. Another project, this is the Ringwood Aqua Center in Melbourne. Here they were using the multi-wall system as the skylights of the building, also in the roofing and also in the facade, and they also took it in matte finish. Matte finish because they didn't want the glare when people go outside of the building, sitting here on the grass, so they don't get the glare in their eyes. And because they were here, the spans are quite big, about 2.5 or 3 meters, which is approximately 10 feet. There was a special span bar system that was being used here. Basically, it's a structural aluminum profiles that are part of the system that can be installed over such large spans. Okay, so for summary, what we talked about today, so polycarbonate in construction. So we have it's lightweight and durable. It's very easy to mold and bend. It's cost effective. It has a very good light transmission. It has a optical clarity. It's excellent thermal and acoustic performance, and it's a sustainable choice for roofing and glazing. What do you get? So basically solid multi-wall and profile panels. You have flexible design options, broad range of applications. So how should you start with your new project? Just study the difference between the polycarbonate solution and always consult with the manufacturer at the early stage of the design. This can prevent a lot of problems that come in the future. Thank you very much. Now is the time to have some questions. So if you have questions, go ahead. So the first question, is there any limitation on cold bending polycarbonate? So yes, there are limitations on cold bending polycarbonate. As a thumb rule, the minimum bending radius is the thickness multiplied by 200. So for example, for 6 millimeter solid sheet, the minimum bending radius will be 6 multiplied by 200, which is 1200 millimeters. Second question, can flat solid polycarbonate be installed in a similar manner to glass in curtain wall applications? So here again, the answer is yes. Solid polycarbonate can be installed with aluminum curtain wall system profiles or with spider clamps. If you use spider clamps, it needs to be at 450 millimeters intervals. For curtain wall applications, it's recommended to use or to specify the anti-scratch resistant solid polycarbonate rather than the standard solid polycarbonate. Another question, can multi-wall polycarbonate sheets be installed horizontally? So no, multi-wall polycarbonate sheets should be installed always with the channels vertically in order to allow the condensation water to drain out. Next question. What are the benefits of using polycarbonate standing seam system over standard polycarbonate sheets? Well, the main benefit of using a system is that you get the sheets and the accessories from a single source. So you don't need to go and source different accessories by yourself. You can also get single point warranty from the manufacturer. The next question, when should I use multi-wall polycarbonate and when solid polycarbonate? Well, multi-wall polycarbonate should be used when the most critical parameter of the project is the thermal insulation. Solid polycarbonate should be used when you want to achieve clear view or the glass-alike appearance. So in simple words, if you want people to sit under a skylight and see the clouds, then you need to use solid polycarbonate sheets. If you want to have a better thermal insulation, then use a multi-wall. Next question. How do I determine the color, light transmission, and haze properties of the polycarbonate? Well, this decision depends on the application. Some of the colors are transparent and some are translucent. If a see-through material is needed, then the haze parameter should be smaller than 1%. It means it will be very clear. And the light transmission should be based on the illumination level you want to achieve. If translucent effect is needed, then the haze should be 100%, and the light transmission, again, is based on the color and the illumination level required. Next question. Will polycarbonate light transmittance deteriorate over time? So Palram polycarbonate products are shielded with UV protection layer that guards against photodegradation, yellowing, and brittleness. This protects the sheets from the harmful impact of the UV radiation and helps to maintain light transmittance and quality for many years. Our products come with 10 years warranty against loss of light transmittance. Upon special request, we can provide an enforced UV protection layer, which provide longer warranty periods. The R value, next question is, the R value starts varying high as the thickness increases. Multi-wall versus solid. Do you suggest double layer sheeting with multi-wall to get the greater R value? So first of all, this is correct. If you need higher values of R value or U value, you can make double glazing solutions or even triple glazing solutions. This is valid for both multi-wall and solid sheets. Of course, if you do it with solid sheets, you will get, if you do it with the multi-wall sheet, you will get much superior U values than doing double or triple glazing with solid sheets. The next question, cleaning of the flat panels. Do the panels in highly corrosive environments attract algae? So the answer here is no. Okay, cleaning the panels does not make them to attract algae. The only issue here is if you're using a multi-wall polycarbonate, then if you spray water on the multi-wall and the edges are not perfectly sealed, water might penetrate into the channels, and stay there, and then over time it might become an algae. The next question. You said polycarbonate can be recycled many times, PVC too. However, if you recycle PVC, it loses the initial characteristics. Would that happen the same with polycarbonate? I mean, the virgin polycarbonate is the same of recycled one. Well, of course, there is a difference between recycled and non-recycled, but just for your knowledge, when we produce the polycarbonate, every scrap we have during the production, we just regrind it and put it back to the production line. This also gives you some credit points. Of course, if you make 100% material from a regrind material, let's say the parameter that will be most affected is the clarity. You will not be able to achieve clear sheets, so mainly it will be used for translucent, but more or less the other parameters will stay the same. The next question. In metal standing seam system, when we fix the polycarbonate sheet, the issue is leakage. How do we fix the clip which you have shown? So I guess this question relates to the soccer stadium I showed you in Germany, where we put a special tailor-made Santaf on top of a perforated metal seam, standing seam roofing. So the aluminum clip is a continuous clip. So basically it's designed to suit the standing seam after it's being seamed. So basically you just place the polycarbonate over the perforated metal, and then you snap the aluminum profile to place. So once you snap it, it cannot be taken apart, and it creates pressure through the EPDM gasket on the Santaf, and the Santaf basically it fixes it to the roof and also prevent water from going in. So basically there is no perforation in the polycarbonate, therefore no leakage because of fixings. Okay, I see there are no more questions, so that's it for now. I hope to see you in our next sessions regarding the roofing and the facade. If you have more questions, you can just contact us through our website and we'll answer you. Thank you very much.